Hi, this is Miss Park, and in this video, we will talk about transformations of parabolas. What you're seeing here is a parabola y equals x squared, otherwise known as a quadratic relation. You can recognize a quadratic relation because of the word quadratic, which means a square. And here is your x squared. Now, a transformation is just, as in English, it just means a change. So we can take this graph, y equals x squared, and transform it, change it to have a different position on the grid, a different orientation, so opening upward or downward, and also a different shape. So in this video, I'm just going to go through the different ways that we can transform this graph individually. And then in the next video, you will see how to graph parabolas when we're putting all the transformations together all at once. So the first kind of transformation happens when we add a number to the end of the x squared. So if I add, let's say, a plus 3 here, what we'll notice is that the entire parabola has gone up 3 units. So if let's just bring this back to the original, and if I have them side by side, one under the other, I will write it like this, x squared plus 3, and you can see them now, one under the other. So the red one was my original, my new one has gone up 3. And what happens if I go down 3 or down any number? I would just subtract. I would just subtract the value, and then you can see the parabola goes down. What's happening is that when the y's are being calculated, they're being calculated from x squared, and then we're changing the y by adding a number to it or subtracting a number. So this is called a vertical translation. Vertical means up and down. Translation means movement. This is a vertical translation. To get a horizontal translation, which means it's side to side, I'm going to put the number inside the bracket. So let's say x minus 5 squared. So now let's take a look at the red one, which was the original y equals x squared. The other one, y equals x minus 5 all squared, moved the green parabola to the right 5 units. So it didn't go up and down at all. It just moved to the right. And if I change this minus to a plus, it moves to the left. Okay, so this is the up and down and side to side. So guess what we can do now? We can move it up and down and side to side by saying this, y equals x plus 5 squared minus 3. And so now that gives us the purple graph. All right, so now this one has moved to the left and down. So the next thing to show you is what's called the a value. So I'll show you the equation in a moment, but the a value is a number that sits in front of the x squared. So I wrote y equals 2x squared. What's happening is the new graph, which is the black one, is being vertically stretched. So vertical stretch means up and down. So vertical means up and down. Stretch means somebody's pulling it so that it's growing at a different rate. This one, after calculating the y's, we are doing times 2, which means that all the y coordinates of all the points are going to be times 2. And that means that this parabola is stretched, it's skinny because somebody is pulling it tall, it's growing faster than y equals x squared. Now I can make one that's growing not as fast as y equals x squared by putting a small number in front. So let's say like a half. This number, which is less than 1, means that this, oh, why is it red? Okay, well then the other red one, the thick red one, is wider than the original red one because all of the y coordinates are times 1/2, which means it's not growing high as quickly. Another thing we can do with this a value, this number in front, is we can turn the parabola upside down. So if I take y equals negative x squared, the result of this is that all of the y values that are being calculated from x squared are going to now be also multiplied by a -1. And so that appears that like the parabola is opening downward. And that is called a vertical, because it's up and down, reflection. The word reflection because it's like a mirror. It's like looking in the mirror and you see your reflection. And I can combine all of these things by saying, oh, y equals negative 1/2 x squared. And now I have a parabola that's vertically stretched by a factor of 1/2, which means it looks like it's squished, and it's opening downwards. It's got a vertical reflection. And what you'll see in the next video is that we can actually put all of these together and have a parabola that is vertically stretched, vertically reflected, translated horizontally, and translated vertically. So that will be in our next lesson. Before we leave this lesson, let's see what happens when we do this without Desmos. So I'm just going to open up a booklet page. Okay, so with the booklet page, what we're going to do is we're going to input values into this table of values here. So this is just a booklet page that talks about the K. So every equation looks like this. Okay, and when we see an equation that looks like this, you can see the y equals x squared in here. There's x squared, but there's other numbers. And the other numbers are the a, the h, and the k. The k is the one that brings the parabola up and down because it adds a number after the calculating the y. The h is the one that moves it side to side, and the a is the one that gives us a vertical stretch and also maybe a vertical reflection if the a is negative. So as we're going through these booklet pages, we're going to be filling in these tables of values like such. So for example, y equals x squared. If I square each of these, we've seen before that these are the values of the y's. To calculate the others, you just input them. So this is negative 2 squared plus 1, which is 4 plus 1, which is 5. Negative 1 squared plus 1, that's 1 plus 1, which is 2, and so on. So you fill in the tables of values, graph them by hand. Graph them by hand, and then we can fill in all of these things that we see from the table of values. From the graph. Okay, and what ends up happening is that the k, how does it transform the basic one, y equals x squared? Well, if k is a positive number, bigger than 0, then it transforms k units upward, and the word for movement upward is translation. Okay, and this one will be translation. If k is negative, translates k units downward. Okay, I'm just going to flip to the page with h. So I'm going to go over here. Okay, so this page over here, what's the effect of the h in here? Well, if I have, this is my original 41014. Again, just input the values and see what happens. So this is going to be a 9. Input the values and you can graph everything, and you will see that what the h does is this. If the h is positive, then it's translation h units right. And you will see it as this x minus h. You will see this minus. There's always a minus there if the h is positive. If the h is a negative number, then it'll be x minus a negative number, which really will look like a plus. So in this example here, you should see the parabola moving to the right. In this example, you'll see it moving to the left. So I'm going to write over here, this is translation h units right. And if we're going to, if h is a negative number, then it's translation h units left. And when I say h, I mean the number part of h. Translation h units left. So if h is -5, it's a translation 5 units to the left. Okay, almost done. We just have this a value. So we saw that if we have a number in front, then these values are going to be multiplied by 2. So I'm going to have 8, 2, 0, 2, 8. And so this is going to make the parabola grow faster. Okay, and same thing with 3. That's going to make it even faster than that. I'm just going to turn the page. And so, okay, so there's no space to write it, so I'm just going to write it over here. So what we have is a vertical stretch by a factor of A. The word factor just means multiplication. So multiplying by A. And then the other thing that we saw with A is that if A is negative, then that is called a vertical reflection. So all that means is take your table of values, input your x, and then turn it negative. So input your x into x squared and turn it negative. This part here is going to be 4 with a negative in front, negative 4. This part here is going to be positive 1, but there's a negative in front, so negative 1. And you'll see when you plot these points on the graph that you're going to have something that's opening upside down, and that is called a vertical reflection. And we can put them all together and see what happens when you have a vertical stretch and the vertical reflection. Okay, so practice on these pages. If you like, you can use Desmos to help. Oh, here's an example where this one is vertical stretch, but it's actually not stretched. It looks like it's compressed because it's not growing as fast as y equals x squared, but we still call it a stretch. We just say it's stretched by a factor of 1/2. Okay, and that's it. So please practice. Hope this was helpful. Thanks for watching.